Balaji, are we ready to start?
Yes, sir. We'll start.
Okay, okay. Good afternoon, everybody. A very warm welcome to everyone joining us today for this insightful webinar on green energy options for building sectors, organized by Puducherry Climate Change Cell as part of the Mission Life Save Energy initiative. We are honored to have Dr. Brahmanand Mohanty as a speaker for this webinar talk. Dr. Mohanty is a renowned expert in the field of sustainable energy and has collaborated with Government of Puducherry in several key projects. He possesses extensive experience and knowledge in renewable energy domain and has made significant contributions through his research, advocacy, and implementation of innovative green energy solutions. His insights on green energy options for building sectors will be invaluable in guiding us towards adopting more sustainable practices in our homes, workplaces, and communities. I take the privilege of welcoming him to our webinar. Welcome, sir. Before we delve into today's session, I'd like to take a moment to acknowledge the significance of Mission Life, a critical national program launched by our Honorable Prime Minister. This ambitious mission aims to encourage individuals and communities to adopt a more sustainable lifestyle by promoting mindful consumption and environmental consciousness. The Save Energy theme forms a crucial pillar of this mission, emphasizing the collective responsibility we share in reducing our energy footprint and mitigating climate change. Energy conservation is not merely a choice, it's a necessity for ensuring sustainable future for our planet and generations to come. Buildings in particular account for a significant portion of global energy consumption. Therefore, exploring and implementing green energy options in this sector holds immense potential for substantial energy savings and environmental benefits. I believe this webinar will equip us with the knowledge and understanding necessary to make informed decisions regarding energy consumption in our buildings. I encourage each of you to actively participate in the discussions, ask questions, and gain valuable insights from Dr. Mohanty's expertise. Thank you all. Now, I request Balaji to give an introduction about our speaker today.
Thank you, sir. I'll take 2 minutes to introduce a speaker to the participants. Dr. Brahman Mahontai is an independent energy and resource management specialist. He has been serving the French Agency for Ecological Transition as its regional advisor for Asia since 1991. He was associated with the Asian Institute of Technology in Bangkok from 1986 to 2020 as a faculty in the Department of Energy, Environment and Climate Change. He has undertaken short-term professional assignments in Asia, but also in the Middle East, Africa, and in the Mediterranean regions. He obtained his doctorate
Hello, hello.
Yes, sir.
Hello.
90%.
Is there a problem with the audio?
Sir, can we start our presentation, sir?
Yes. Thank you. Uh, can you hear me?
We are trying to present the screen, sir. Just
Okay.
hold on for a minute.
I can see the screen. I can see the screen.
Yes, sir. So it's clear, sir. We may start now, please.
Okay. Thank you. Thank you. I'm really sorry for the inconvenience with my internet. I would first of all like to thank the Pondicherry Climate Change Cell as well as the Department of Science, Technology and Environment for inviting me for this webinar. And I would like to share some of my experiences, and I'd like to make my presentation as simple as possible with a few explanations, followed by concrete examples so that those of you are attending it would be able to understand. And this example is from Puducherry itself. Next slide, please. My presentation would be, next slide, please. Can you hear me? Can I have the next slide, please? I would cover 5 topics. First one is the energy demand versus energy supply. When you talk about energy conservation, efficiency, etc., all that comes into the domain of energy demand. And I would discuss a little bit about what is energy demand and versus energy supply. And since our topic is related to the building sector, why we need to focus on the building sector, and what is the ideal path to achieve zero energy or zero carbon buildings. Because this event has been organized by the Climate Change Cell. We are talking about the impact of human activities on the climate, local and the global climate. I would conclude by a case study of a building in Puducherry, followed by a short sensitization video. Next slide, please. I would request all of you to mute their speakers so that there is no disturbance. So in the picture that you see, you have a balance, and on one side we have the left side is all the energy supply in different forms. Fossil fuels being the most dominant one at present. Almost about 80% of all the energies that we use come from fossil fuels. We are heavily dependent on fossil fuels, but we are also looking at alternative renewables, such as solar, wind, hydro, bioenergy, etc. And on the right side are our energy demands from our homes, businesses, offices, industries, transport, and agriculture. So the more we demand, the more you have to find sources to meet our demands. So at all times, we need to look at how we can keep a balance between our energy demand and the supply. And whenever there is an imbalance between the demand and supply, we will face a crisis. We have seen that in the past, that very often we used to have power cuts because the demand of electricity was higher than what our power plants could be supplied to us. So the planner's objective is to make sure that we are always in phase between the demand and the supply. If the supply is not enough for the demand, there'll be demand disruptions, which is not desirable because it will have negative impacts in terms of productivity, in terms of health and comfort of people. Okay. Next slide, please. The next slide shows us how India meets its energy demand. The slide shows from 1965 to 2020, just around the time that we had COVID-19. You can see that India has been heavily dependent on fossil fuels, with the predominant one being the coal. And this is not only electricity, it's all forms of energy that are used. Coal, mainly for power plants and industrial activities, oil for transportation mostly, So that itself is the major part of our energy supply, followed by all other small ones, like you can see nuclear, hydro, wind, solar, etc. But the scenario has changed in the last 3-4 years. We have been trying to increase our renewable energy capacity quite a bit so that we can keep up with our rapidly rising demand. You can see the demand has been going up very fast in the last, let's say, between 1980 and 2005 or so. And then the slope has been much more accentuated. That means our demand has been growing faster due to the economic growth. Okay. So if to cope up with this demand, apart from the dip that we see due to COVID, otherwise the demand has been keeping on rising at a very rapid rate. Next slide, please. So as a result, we are facing the challenge of the demand being much greater than supply. And if some of you may have seen the International Energy Agency's Energy Technology Perspective Analysis, which was done a few years back, they tried to see how we can achieve zero emission in future. And they had looked at various research options, the technological options that were there. And one of the blue map emission scenarios shows that they can achieve an emission reduction from 57 gigatons to 14 gigatons by various technologies. And the most prominent one of them being the last one, which shows at the bottom, end-use fuel and electricity efficiency, accounting for 38%. So that's where we can see efficiency improvement in the use of fuel and electricity can help us to reduce our emissions by as much as 38%, followed by the next important one is renewables, which is about 17%, then end-use fuel switching, etc. So this shows clearly that the two key technological options that we have are energy efficiency and renewable energy, how to mobilize both of these to reduce our demands so that one of them, end-use fuel efficiency, will help us to reduce the demand, whereas renewables will help us to create additional supply to meet the growing demand of energy in the world. Next slide, please. So how do we achieve a balance between the demand and supply? To reduce the energy demand, we have two options. One we have seen earlier, the IEA's technology option, which being energy efficiency. But actually there are two parts to it. One is energy efficiency, which is more technological options, which basically says, how can we do more with less? Or how can you continue to do the same thing with less? And the other one is non-technical measure, which is related to energy conservation. And this does not require any technological interventions. This is more related to how do you manage our energy better? How do you bring about behavioral changes, lifestyle changes by which we reduce our demand for energy when there is no need for it? Okay. For example, we see sometimes there is no need for air conditioning when the outdoor conditions are good, and yet we are using an air conditioner. And that's a way of how do you achieve behavioral or lifestyle changes so that we can avoid the use of energy. And on the supply side, we have the renewable energy sources, which will help us to not only meet the demand, at the same time, lower the greenhouse gases. Thereby, we can achieve our zero carbon targets in 2017. So doing this, we hope to achieve conditions where the demand and supply are stabilized. At the same time, we are not using the supply side sources which are polluting to the environment, which are not emitting carbon dioxide and other emittents which are bad for our global environment. Next slide, please. So now we are going back to the two technological options that we talked about, energy efficiency and renewable energy. So energy efficiency is also known as the low-hanging fruit. On your right side top, you can see there's a tree bearing lots of fruits. So if you had to pluck the fruits, would you like to first take up a ladder, go up to the top and look for the fruits? Or would you like to catch the fruits which are within your hand's distance, okay, which is easily reachable. So which is reachable is also known as the low-hanging fruit, and energy efficiency is considered as the low-hanging fruit compared to renewable energy. And yet people get more excited to go for renewable energy, putting rooftop solar or on-ground solar, wind turbines, etc. Those are supposed to be fruits which are on top of the tree and more difficult to achieve. But we go for them because they are feasible to us. Whereas when we talk about energy efficiency, there is no actual physical device that you're going to put in the same device, which is designed engineering from the engineering point of view in a more efficient manner. So we don't really see it visually, just like we see the wind turbine or a hydropower plant or a solar photovoltaic system. But energy efficiency has a low cost in the beginning. It is just like, if you start churning the milk to get the cream out of it, initially it's very easy for you to churn the milk to start getting the cream, the butter out of it. But as you want to get more and more, you have to work harder and harder. Next, continue please, so that you can see how the energy efficiency initially, with a small effort, with a small increase in life cycle cost, you can achieve bigger savings, energy reduction in energy demand. But as we move on the blue path, next step, our life cycle cost will keep on increasing, whereas the energy demand reduction will be much less in each step. So just like I gave the example of churning the milk to get the cream out of it, initially it is very easy from getting savings from energy efficiency. For example, if you change your incandescent bulb to a LED lamp, you can get back the money within a very few months' time. Whereas if you go to change an air conditioner or a refrigerator, it might take you a few years. So depending on the type of interventions, depending on the type of technologies, some of them are easy to achieve with a little cost, whereas some others, it will require much more efforts. So the beauty lies in how do you combine energy efficiency and renewable energy in such a manner that when the cost of increasing the efficiency becomes too high, you switch over to renewable energy, because that's where renewable energy makes more sense. So a combination of both energy efficiency and renewable energy can help us to balance the difference between the demand and supply. It will help us to reduce our demand from energy efficiency, which is also known as virtual power plant. Energy efficiency does not require to create new power plants, because it will help us to reduce our demand, which is also known as the megawatt. Instead of creating megawatts, we will be creating megawatts, which will help us to avoid the need for that energy. Okay. So as they say, the cheapest form of energy is the energy that we never asked for. So energy efficiency is like, if you're using an appliance today, which consumes, let's say, an air conditioner, which demands 1 kilowatt, if you go for an efficient inverter air conditioner, that may require only 0.6 kilowatt. So you'll be helping to avoid 0.4 kilowatt. And that is the 0.4 kilowatt that you would not require, for which you don't need to build a power plant, which is much more expensive. So the challenge is to find out to what extent we can go for energy efficiency, because the more we want to go for the higher efficiency, the cost becomes high. And renewable energy comes in at some point of time where the red line is crossing as at blue. Beyond that, renewable energy starts becoming much more effective. Next slide, please. So that's just the introduction between the demand and supply, energy efficiency, and renewable energy. What is the difference between the two, and why it is important to judiciously combine both if you want to achieve our sustainable energy goals of achieving zero energy and zero carbon in future. So the topic is about the building sector. So I would talk a little bit about the building sector itself. In the past, we didn't have access to any of the present energies that we're using, whether it is the fossil fuels, even coal, oil, etc. We dependent partly on biomass. By burning, we could cook, And in the houses, we didn't have electricity. So typically those buildings were zero energy because we didn't have access to energy. And later on, zero energy when we started putting wind turbines, for example, windmills to carry out certain activities. Next, if you press, you'll get the next one. We achieved what we call a net positive energy building. This is long time back when you started operating windmills to carry out mechanical activities, for example, grinding grains, pumping water, etc. So a building which did not have any demand for energy, we started producing more energy than what is required. Unfortunately, as we started depending more and more on fossil fuels since the Industrial Revolution, over the last 200 years, the picture has changed to a point now that in the cities, you will find buildings which are full of glass, particularly in tropical climate. Next, please. On your right side, you can see the picture of typical buildings that we see now. Next slide, please. You can see more and more buildings, high-rise buildings, which are full of glazed facades, and the glazed facades are capturing the solar heat and putting them inside. So making the houses like ovens, and we are obliged to use air conditioners to remove all that heat by using more and more energy in the form of electricity. Next slide, please. So this is a slide which shows how the building sector has been emitting in the past and what is the trend in future. So you can see in this picture, the dark red is the past scenario, and most of the buildings that were emitting greenhouse gases were in the developed world, in the North America, in Europe, etc. Whereas in most of the developing countries which are around the tropical belt, the energy consumption has been low in the past. But the future shows that the demand with the light red color shows that most of the demand would come from developing world. That's where the population is rising, and there is bigger demand for energy because there is need for housing. More and houses are being built. Houses require energy in two forms. One is the materials that we use to build the houses, and the energy that we use to operate them. So as we construct new houses, we require raw materials in the form of bricks, cement, concrete, glass, metal, etc. And all these are very much energy intensive. The industries that produce them require a lot of energy to manufacture them. We call them embodied energy, the energy that goes into the building itself. And the embodied energy is not negligible. On top of that, these buildings that last for 50 years or more would keep on using more and more energy if they're not well designed. Okay. So as the climate change occurs, the temperature will rise further. We'll require more amount of cooling to take care of these buildings. Next slide, please. So as a result, we can see slowly there is a revolution to switch over from the traditional fans that were sufficient for us to take care of our cooling requirement. Gradually, there is a shift to air conditioners, though the shift has been very, very slow, and still a very low percentage of Indians use air conditioners. But we can already see in the cities, the photos that you can see on your left-hand side, you can see this is a common example of how the outdoor units of air conditioners are mushrooming out, and actually they're throwing out a lot of heat to the surrounding, making the atmosphere even more warm for people those who are around it. So each building that was using a fan in the past is using an air conditioner. Immediately the energy consumption goes up by 20 to 30 times, depending on how efficient the air conditioner is. And as a result, some of us, those who can afford to have air conditioners, are actually creating a more conducive environment for us, whereas we are throwing out all that heat, making it uncomfortable for most of our neighbors who cannot afford to have air conditioners. As a result, there is a race to have more and more air conditioners. On the right-hand side, you can see there is a Netherlands Environmental Assessment Agency's prediction that by the 21st, end of 21st century, there'll be 40-fold rise in air conditioners use. And you can see from 2020 onwards, there is a rapid rise of air conditioner. And this is exactly what we can see every summer comes. More and more people are going to equip their houses with air conditioners. Whereas heating doesn't go up so much because heating is mostly required in temperate climate, which are mostly in developed world, where the developed world have regulations to design buildings more efficiently. As a result, they do not require so much of heating to take care of the cold winters in those countries. Whereas because our buildings are not properly designed, the buildings are becoming ovens, and we don't require more and more air conditioning to remove these heaters. Next slide, please. This was a Lawrence Berkeley National Laboratory study for India. It shows that air conditioning was growing at about 20% per annum, which is very rapid rise because our baseline was very low. But it says by 2030, the demand would grow so much that we would require about 300 new coal-fired power plants, each of about 500 megawatt. So we do need to look at how we can make our buildings more efficient by designing approaches. And then we require to look at how we can make our appliances that we use in buildings much more efficient so that we don't require so much amount of energy, both in the form of thermal as well as electricity in the future. Next slide, please. So the global challenge is how to ensure that we remain comfortable without necessarily cooling our buildings or requiring very little amount of cooling in future. Unfortunately, if we do not design the building properly, we are obliged to bring in air conditioner to remove all the heat which is trapped from outside. This slide is interesting, which shows what is called the MAC curve. This curve is typical curve which shows what is the cost of adopting some of the technologies. And you can see the costs are shown on your y-axis as negative costs. Some of the, in the beginning, some of the technical options that we have a negative cost. These negative costs are compared to what is the cost of supply versus what is the cost of demand. So this is a typical example of how we can do a study to show that some of the measures have payback periods which are much shorter compared to the payback periods that we incur when you go for energy supply options, whether it is any types of renewable, wind, solar, etc., which have a longer payback period, which are good for the environment, but the initial investment takes longer time to get back. Whereas many of these demand side measures have a negative abatement cost. That means every kilowatt hour that we avoid to use for these with these technologies will have a negative cost compared to going for a power plant. So this is again supporting the earlier picture that I showed. Initially, to a certain extent, let's go for energy efficiency. When the energy efficiency cost becomes high, as it is shown on the right-hand side here, we need to switch over to other forms of energy, which are mostly renewable energy side. Next slide, please. So this is showing you a little bit on what is the ideal path. Let's imagine this pyramid is representing a building whose energy consumption and carbon emissions are shown by the green arrow at the bottom. So that is the total amount of energy that is consumed and carbon which is emitted every year for a typical standard classical building. And if you want to change that, we need to look at it in 4 stages. The first stage is to look at, next slide, please. If you can bring about behavioral and lifestyle changes, this is what the LiFE program of the government talks about. How can you achieve reductions, impact on the environment by our behavioral and lifestyle changes? These are simple options. For example, adhere to adaptive comfort. We are in a climate where we can withstand easily, let's say 28 to 30 degrees Celsius without an air conditioner. So why do we need to keep our air conditioner set at 22 degrees? Why do we need to start air conditioning when the outdoor condition is quite favorable? It's just for us to open the windows and benefit from the good natural air which is outside. So this is a behavioral approach. Similarly, you can take some actions to control the indoor environment. There's no need to set it at a very low temperature. Very low temperature means we don't feel comfortable. We lose our energy at the same time. We are throwing much more heat outside, which keeps coming back to us. So behavioral and lifestyle changes are adopted while designing building. We already start seeing that energy consumption and carbon emissions become smaller because the pyramid is much smaller. We have eliminated the lower rung with zero incremental cost. Behavior and lifestyle changes do not require any investment, so they have zero incremental cost. Next step is to how do you design the buildings properly? How do you integrate the designing to suit the location? How do you bring in the different features that are there? Uh, for example, orientation of the building, solar protection, overhangs, making sure there is good cross ventilation, the building indoors are lit properly without having exposure to direct sun. So these are some of the basic bioclimatic and passive architecture principles. I know that a lot of materials are already there on the website of the Climate Chill Cell. On top of it, you have had very technical presentations in the past, so I don't want to repeat through all of them because the time is short. I just want to go over the overall concept of it. So you can see when you do integral designing, by designing the building properly, we can not only reduce the consumption, at the same time, we reduce our dependence on equipment, which will help us to keep our buildings cooler or warmer, at the same time to provide daylighting as much as possible so that we depend less and less on artificial lighting, etc. So this will have a low incremental cost. And the next one comes with the energy efficiency and conservation. Next slide, please. So the third step is looking at how we can choose the most energy efficient products, equipment and appliances which are available in the market. Next one, please. Yes. So you can see energy efficiency and conservation comes in by which we can choose the most energy efficiency appliances. Today, the initiatives that are taken by the government of India through the Bureau of Energy Efficiency of the central government is helping us to know which are our electrical appliances which are more efficient through the Energy Star program. The more the stars, the less the energy requirement, more money saving we can have. So this is helping us to choose the right equipment and use them only judiciously when it is required. So that leaves us, as you can see, the pyramid has become much shorter and our energy consumption and carbon emissions have come down because of the first three measures that we have taken through behavioral lifestyle changes, integrated designing, followed by efficiency and conservation. The last thing that we can think about is how to use, how to look for renewable energy options. Next slide, please. So the topmost one is, as you can see, the remaining energy that we can't meet with behavioral changes, energy efficiency, etc. We can look for renewable energy on site if there is a possibility of on-site renewable energy generation. If it is not possible on site, we can look for it from investing somewhere else so that we can offset our requirement, energy requirement, as well as our carbon emissions from the building itself. So that's the best way. Next slide, please. We can achieve our zero energy or zero carbon in a building by going through systematically through 4 steps: behavioral lifestyle changes, integrated designing, followed by energy efficiency and conservation, and finally looking for renewable energy. So to illustrate this, I have looked into one of the buildings. Next slide, please. It's a case study of a building in Puducherry, where, of course, the building was already built, and this building was constructed during the colonial era. So already they had, that time there was no electricity, there was no fossil fuels, so the building was already designed in such a manner they could capture maximum daylighting, whereas they could protect themselves from the direct sun inputs. The orientation was such that they could provide cross ventilation. There were lots of openings, so by which the building's energy requirement was much less, and only at night they had to look for ways by which they could provide some lighting. But this building has changed over a period of time. So already, as I talked about, the designing aspects was taken into consideration, and they wanted to look at, the owners of this building wanted to look at how they can minimize the dependence of the building on fossil fuels, because at the global level, there is a trend to achieve low carbon followed by carbon neutral development. So this building, they wanted to showcase how they can go from the present status to a more low carbon status by taking up some actions. And the first thing that they talked about is how to commission a rooftop grid interactive solar power plant. And they found it was a challenging task because the rooftop area was very small compared to the energy demand of the building. So they had a limited capacity to meet their energy requirement through renewable energy option from the rooftop solar plant. Next slide, please. So this is a building, as I said, is heritage building of historic importance. It's over 250 years. There's 2 floors, okay, and it has high floors, mezzanine floors were added in some parts of the building, and it's used both for office and residence. As I mentioned, there was a constraint in installing solar power plant on the rooftop because of the space limitations on the roof. So preliminary study was done, survey was done, and they found out that the building had many old and inefficient appliances. Next slide, please. So these are lamps. Many of them were incandescent lamps. Air conditioners were very, very old. They're making noise. At the same time, they're consuming high amount of energy. Many of the office equipments, whether it's computers or printers, they were high energy consuming appliances. Okay. So the first proposal was to replace these inefficient appliances by more energy efficient alternatives. And investments on these measures, which are known as the demand side measures, because these are going to help the reduce the energy demand itself. And that will help in not only reducing the energy savings and reduce the demand for electricity. Also, the capital investment that is put in there will be recovered at a much faster rate than the money that is going to be put for renewable energy generation. For example, a solar power plant would require a payback period of 10 years. Some of these measures can be recovered. The investment in these measures can be recovered within, let's say, 2, 3, 4, or 5 years' time. So that was the premise on which the objective was revised. Next slide, please. So the new objective that was set was to identify the potential energy saving measures and select only those that were implemented in priority with payback period shorter than that from the solar investment. And you remember the graph I showed, energy efficiency becomes more and more expensive at one point of time. Renewable energy starts kicking in as a more viable option. So this is the same principle which was followed here. And the remaining capital will be mobilized to commission a rooftop solar power plant. So it was a combination of how to bring in more efficiency, reduce energy demand, and then look at alternative for replacing the present use of fossil fuel-based electricity to solar electricity. So another component, next please. Another component was to study also how to set up a baseline to know where they are today and monitor after the equipments have been installed, the solar plant has been installed, to see what has been the actual results from these measures. Next slide, please. So for this, initial studies were done to see what is the consumption in the past 4-5 years, and this is from 2011 to 2015. Last 5 years data were analyzed carefully, and which helped to make a correlation between electricity consumption. Next slide, please. Electricity consumption was due to 2 measures. One was due to the activities. So whenever the office was being operated, the demand would go up. So in the residential areas, the demand was much smaller. Next slide, please. And you could see very clearly, next. You could see clearly on your right side, as the temperature, ambient temperature kept on rising, which is measured by something called a cooling degree days. How much of, if you take a baseline of where the cooling is required, as the days become hotter and hotter, you have more and more cooling days. So the data that were taken to show that as the days become hotter, the electricity consumption was much higher because more air conditioning was required to keep the building comfortable for the occupants. So activity and climatic conditions both were looked into, and wherever there was options possible, analysis was done to find out how to improve the performance of the building. So the baseline shows in the next slide, based on the area of use as well as the energy consumption, they came up with a number of present consumption before the modifications were done, before the renovation. The annual energy consumption was taken and the area was taken to find that the building consumed 88 kilowatt hour per meter square per year. And this is very good because according to the Bureau of Energy Efficiency, next slide, a 5-star rated building which is located in a hot and humid climate, if it consumed less than 100 kilowatt hour per meter square per year, it was considered to be a 5-star rated building. Whereas in the case of this iconic building, because it was well designed, already it had a figure of about 88 kilowatt hour per meter square per year. So it was, according to the Bureau of Energy Efficiency, it is already achieving the 5-star rating. But the occupants of the building wanted to go further because they want to achieve low energy and low carbon building in future. Next slide, please. So the main uses of electricity were mostly air conditioners, indoor and outdoor lighting, followed by office appliances and uninterrupted power supply for some of the applications which were required in the building, water pumps and fans. These are the ones in office buildings, and the residential, of course, similar type of appliances were in use. Next slide, please. So the audit shows that the office accounted for 93% of the energy, whereas the residential had about 77% of energy. And in the office, 2/3 of the energy was mainly for air conditioning. So it was very important for them to choose more efficient air conditioner by which they can reduce the demand for energy considerably and reduce the overall electricity consumption as well as the bill. Next slide, please. So based on these, the different solutions that they found out from the demand side to reduce the energy use, they've identified up to 57% of energy can be saved, which is about 137,000 kilowatt hour per year. But the capital investment will be about 70,000 rupees and overall payback period will be about 58 months. So there again, they decided to choose only the ones which will have shorter payback period than 58 months. So instead of looking at all the 57% savings, they reduced the solutions. You can see the next slide. They decided to change all the inefficient lamps by LED lights. About more than 50 air conditioning units were replaced by multi-split variable refrigerant flow air conditioners, which are much more efficient compared to the standard split air conditioner or window type air conditioners. They use inverter and high efficiency split air conditioners by which considerably. On the supply side, they decided to go for a 45 kilowatt solar power plant using 2 inverters of 30 kilowatt and 15 kilowatt each. So the capital investment for the demand side, we had seen earlier it was higher. Next, please, you can see the numbers. If you press the slide, you can see the numbers, please. Yes, capital investment for demand side was about 53,000. So it was not all the measures that were identified, only those measures which gave a payback period less than 5 years. And the supply side, the capital investment was about 49,000, more or less the same type of investment. And the payback period was slightly more, it's about 7 years or so. Next slide, please. So you can see the demand side measure, capital investment and payback period, and supply side measure, capital investment and payback period. So rooftop solar had a longer payback period compared to the payback period with the energy efficiency measures, but the combination of the two will allow them to achieve much better results. Next slide, please. So this is after 1 year of operation, replacing the equipment as well as installing the solar. You can see Bureau of Energy Efficiency standard, which is 100 kilowatt hour per meter square per year. The building baseline case was 88 kilowatt hour per meter square per year. Through energy efficiency, they could bring it down to 65 kilowatt hour per meter square per year. And thanks to the renewable energy on the rooftop, they could bring down their energy requirement to only about 38 kilowatt hour per meter square per year. That's a huge reduction from 88 to 38. And that compared to the 5-star rated buildings, is much better. So you can see gradually they have managed to achieve low energy consumption and low carbon consumption with the limited space they had, because it's not a new building, it's a building which already was existing. Next slide, please. So this is just to summarize. You can see this building, starting with energy efficient appliances, helped to reduce the consumption by 27%, and solar rooftop solar provided to reduce the dependence on fossil fuel based electricity by another 31%. So they're left only with, on top you can see the fossil based electricity now is about 41%. Okay, so about 59% of electricity was able to save this. With this, I come to my end of my presentation. I had a short video. If you can just show that, this is again in Puducherry. It was meant more to sensitize the school children about how a building can achieve low carbon emission through various measures, both on the supply side as well as on the demand side, energy efficiency as well as rooftop energy. Thank you. You can start this video if there's still time. I guess the sound is not working. If it doesn't work, doesn't matter. I would request the climate change cell I will provide a link so that they can share with all the participants, because without the sound, you will not know what is happening apart from seeing some images. Okay. So perhaps I've taken my time. I leave some time for any questions and answers or discussion. Thank you very much for your attention. I'm sorry for this shorty presentation because there is no.
Secondment faculty, through the secondment faculty. And yeah, of course, I just heard all the slide what you are explained. So basically I am from of course my native at Puducherry only.
Yeah, thank you. I'm sorry.
Yeah,
it's been long.
I'm at my native is in Puducherry, and of course when you giving the lecture on like a kind of building capacity for Puducherry city, so I am really happy about that. And of course we are also working on like a building capacity with a solar dryer, like we used to work on solar dryer especially. And then we used to work on decarbonization, green hydrogen and decarbonizations. I'm actually professor at Department of Chemical Engineering. My work area is green energy and then hydrogen production. My voice is audible.
Okay, sir.
Hello.
I can hear you.
Yeah.
Since
thank
the
you so
topic,
much.
they
Thank
had
you so
asked me
much
to
for
talk
your
about
confirmation.
energy
Thank you so much.
efficiency.
Yeah.
Thank you.
So yeah, that is what I have seen your slide and your thought of green building with kind of your climate change. Fantastic talk. I really like with that. And then I thought I want to interact a few seconds because maybe we are at Colicut AIT Thailand, so better I should talk to you. Okay, so Professor Mogunti, I want to only one questions regarding the
Yes.
you talk about the kind of we can save the different energy and we can even go into the uh, proper carbon neutral or carbon emission, control the carbon emissions. So in when you talk about this kind of the solar system, from the solar system,
Yes, sir.
of course it is a
Yes,
very
sir.
good efficiency, no doubt. But
Yes.
we feel that it depends on the season. Okay, season as well as the depend on the I can say that zonal angle. What we are
Yes.
going to project it. So how it can can you give some ideas how the Puducherry can be located the inclined angle as well as the uh, as the solar applications? Can you please brief that?
Sure, I will. What you're saying is the output from the solar systems will vary according to the season. And there are certain seasons it will be much less compared to the others. For example, rainy season or winter season where the sun is further down in the south, the output will be less. But that's the whole beauty of buildings. If you design buildings properly with all the protection, automatically you can see in certain days, in let's say winter and cooler days, you would not require to run your air conditioner. Okay? For example, in my house today, I'm not using an air conditioner. I only use it when it is summer because my house has been designed in such a manner that I don't use any artificial light. For example, I'm sitting in a room where there is no uh, artificial light. I'm using the natural daylight. Maybe I'll switch on the video so you can see.
Yeah, I'm seeing.
You can see the
Yeah,
outdoor
it is visible,
area.
visible. Yeah, yeah, of course, of
So,
course.
so, so I don't need any lighting or air conditioning. I'm using just a fan, which is an energy efficient fan. And again, the fan is just next to me. I'm not using a very big fan. It's a small fan which is rotating at a very low space. So now my energy requirement is hardly about, let's say, 10 watts. With 10 watts, I'm quite comfortable. I don't need to use a lot of energy. So when my energy generation is low, automatically my requirements are less because when the weather is not favorable for the sun, it's not that hot. So most of the energy that I showed is about two-thirds of the energy goes for cooling of the building. So that requirement is much less. So it's a question of, I gave you the 4 stages. If you combine them in a judicial manner, uh, also looking at your behavioral change, because the normal tendency is you come into the room, just switch on the air conditioner. We don't look at whether we need it or not. Okay? Many offices, we just go in. We don't see what is the outdoor condition. We just go and switch it on. If we are a little bit more conscious, we'll find that just opening the window, getting some fresh air is much more healthy for us than to sit in an air-conditioned room where the outdoor conditions are most favorable. So I think the natural energies that we get, they are in sync with our requirement of energy to make ourselves comfortable.
Yeah,
Obviously, I
Professor.
didn't go through the details. Yes, please go
Yeah,
ahead.
sure, sure. I understand your answer. And Professor Mohanty, actually, what happened? These are all exactly I understand. But what happened? How we can transform to the though in the village side as Puducherry consists of several village part. So how we can transform this kind of ideas, because you know that as I am teacher of here, so sometimes what happen when we want to transfer any knowledge or any kind of technology to the common people, it's a little difficult to make them to actual application of this building capacity and other things. Okay, so that how you are, yeah, how you, what can be your ideas, how we can materialize to transform this technology to the village actually,
Okay,
village
good
people.
question. In many of the cases, actually, there is no additional cost involved in designing these things. When you design them properly, actually, you might even save energy, particularly if you're talking about rural areas. In rural areas, very few people actually use air conditioner. So obviously, when you design the building properly, okay, but unfortunately, our tendency in the cities, we are designing building very poorly, and there is a tendency to imitate, to copy the same type of buildings in rural areas, okay, using cement, concrete, and just the type of buildings. In rural areas, you have much more space. Instead of using the space properly in a judicious manner in providing outdoor climate which is much more favorable. For example, having trees around, which allows the air to move at the same time, making the solar protection on the walls. So walls don't get heated. And when the wind blows, you're very comfortable. So these can be done. For example, Auroville is not very far from Pondicherry, and there are many houses which are designed with these principles. And many of these buildings do not require any air conditioning, and they're much more comfortable, just because you have created the microclimate, which is much more favorable to them. So that's the reason why I didn't go into too much of theory in my presentation. I tried to give an example, concrete example of what has been done, including the video that is of my house. For the last 20 years, we are energy positive. We produce more electricity than we consume because we use energy efficient appliances. Our building has been designed where we get natural ventilation and daylighting all the time. Daytime we practically don't use electricity for lighting anywhere, and air conditioning is only used in our bedrooms. Again, not in bigger spaces, in a smaller place where we want to achieve with air conditioning only to remove the humidity. Our objective is not to cool down the room. If the building is cooled down to about 28 degrees, we are very happy with it because that's the temperature we're used to. Okay, so I wanted to give those concrete examples to show that it is very much possible. We are not just talking theory. I try to practice what I preach. So these examples I gave, also the building that I talked about, that is the French consulate building. I had interacted with them to help them to bring it down to, you saw about 41% of their past energy demand through energy efficiency and renewable energy. And they're very happy because they're much more comfortable. At the same time, they know they're not so much dependent on fossil fuel. And when I did it in 2016, electricity price was much lower. In the last few years, 6-7 years, the electricity price has gone up. So they are even more happy because the payback period that we had calculated that time is much shorter than that because of the hike in electricity tariff. And we are going to see much more hike in electricity tariff as the cost of constructing new power plants becomes more expensive. At the same time, we have to implement measures by which we can reduce the emissions from these power plants.
Yeah, that is. Thank you very much for your actually. I hope the positive energy maybe transform to the all people of Puducherry, and then I hope all participants really enjoy this real wonderful talk, and I hope the positive energy we can emphasize keep on in coming days to the Puducherry people. So I hope all very best to your life as well as healthy life also. Okay, so thank you so much for your explanations. Thank you so much.
Yeah. Thank you, sir. Thank you, sir, very much.
Thank you, sir. Thank you, Dr. Suresh Sundaramurthy, for the interaction. And if other participants have some query, can feel free to discuss with our speaker today. We'll take some 30 seconds for some other participants to share their questions. Participants, if you have some questions, you can clarify it with our speaker. Sir, I have a question, sir. Sir, you are muted.
Okay. Please go ahead, please.
Yes. Sir, I have a question. Like, in case we are designing for a net zero village.
Yes, sir.
Okay. So in that states in India, I'm sure the share of energy, like a major part for now would come from the fossil-based energy, but the other share, say for 20% or 25% of the energy, is sourced from the renewable energy, say wind purchase from other states or renewable purchase from other states. And if that energy is routed to a particular village, can we claim that as an emission sink? I mean, emission neutralizing. But I'm comparing this with another scenario in the sense that if I'm promoting organic food, and if I source that organic food from, say, Kerala, and all those organic food is supplied to that village in a sufficient quantity, that village, all the food that is taken in the village is organic, then I can very much claim that it is completely an organic food. But electricity is not such a confined good. goods, like the procurement does on paper. But when I claim to route that renewable energy to a particular village, can we take that to assume that the energy is neutralized, sir?
Yeah, thank you for your question. From what I understand, that you wanted to say that there are various sources of carbon emissions. One is energy, and energy happens to be the most dominant one at present. But also all of the other activities, whether it is from our food, because the production of food itself also has emission of carbon. So you talked about how do you account for them. So the typical approach is to account for all of our daily activities and see which activity is contributing to how much of emission. Okay, so there are some direct emissions. Again, I would not go into the details because these are documents which are available. Direct emissions which come from energy in the form of fossil fuel that we're using for heating or thermal applications or electricity. But we also have indirect applications, for including the transportation. Okay? Indirect application, that means, for example, the shirt I buy, how much amount of emissions has been created in producing that shirt, to transporting that shirt to the market from where I buy it. So we need to account for all the emissions. Okay, so from that perspective, we have to see in which areas we can do actions. It's not just the talk. Today's talk was about energy. That's why I emphasize on that. But when you're talking about achieving low carbon, it is not just through energy. It is through our lifestyle, through our way of we consume things. So sustainable production and sustainable consumption, they're both important. Just like I talked about energy today, sustainability of the demand and supply is important. Similarly, sustainable consumption and production are also important. And how we become more informed decision maker in terms of what we are consuming. So when we become more informed, we will choose the products which have less impact on the environment, which are more healthy to human beings. So we're looking at all the three pillars of sustainability, both economically they're viable, in terms of human factors, they're good for the society as well as for the environment, they're good. So whenever we achieve this triple bottom line, we can be sure that those solutions are good. And that's why I was very careful in making my presentation. I didn't talk about taking all the efficiency measures. We looked at the efficiency measures which will pay it back within 5 years, which is something which is acceptable to most human beings. Okay. And the consulate, French consulate, went for solar because they really wanted to reduce their carbon emissions related with the energy that you use. So they went for solar system. Okay. That is not enough. We need to look at all aspects of wherever we carry out activities, human activities, which have impact on the carbon emissions. So your point of talking about food as well as energy, both of them are valid. We need to look at both aspects, okay, and not just say that we do something about energy and not with food or with other activities that we have. For example, transportation. So in my house, we decided not to produce electricity not only for the house, but all our local transport requirements are all also made by the solar. So for the last 20 years, the car that we use is electric car, which is charged by the solar. We don't go to a petrol station. Okay? Our two-wheeler is run with solar electricity. So we not only look at that, our rooftop below the solar panels, we try to grow some vegetable. That's our way of saying that, can we grow some food in our house so that we don't have to go and look for it somewhere else? Okay? It's not that we are going to produce 100% of our food, but we become conscious when we grow food on our own. We're using organic way of food production. So I won't mind when I go to the market to pay a little bit more to get organic food, because I understand the benefit of it, not only in terms of environment as well as my own health. I'm eating more healthy food, and I become conscious about that instead of putting money somewhere else, which is having greater impact on the environment. I prefer to go for more organic food, which is healthy for me as well as healthy for the environment. So we have to look at it in a more holistic manner and not just cherry pick some of them and say that, well, I'm doing enough. So in the same way in the city or in the state of Puducherry, we can't just look at one aspect of it, since the climate change cell is looking at all aspects of it. We have to look at all aspects of our human activities, whether it is in the building sector, in transport sector, in industrial sector, in commercial sector, all of them, agriculture, including agriculture, in all those areas, what can we do to reduce our impact on the environment? What can we do to reduce the impact of that on our human health? Forget about the environment. Now, cities are very polluted and they have impact on our human health. So it's not just about the global environment. We also need to look at how we can remain healthy without spending a lot more money on healthcare and medical bills. So we have to look at it in a more holistic manner than in a piecemeal basis, just saying that how much quantitatively I have brought down in some areas without making efforts elsewhere.
Okay.
We could have a full session on this, but I think I won't like to take too much of time in this. But we can have one-to-one discussion if you wish at any time.
Yes, sir, definitely. Thank you so much. So if there are no more questions from the participants, we'll conclude this webinar. So I take the pleasure in giving the vote of thanks. First of all, sir, thank you so much for accepting to this webinar and for taking the time in making a very insightful presentation on the topic energy efficiency and green energy options in building sector. It was a very effective presentation, sir, highlighting the global scenarios and elaborating on the practical and the best means of tapping renewable and green energy for building sectors. So your explanation on this energy demand and life cycle and the cost assessment, it was all very scientifically insightful. Thank you so much for that. And especially thank you so much for highlighting to one building as a case study, which is in Puducherry, which we could all relate to very well. And in fact, I must also thank you and appreciate for the way the content was delivered, although it was very technical one, but visually and verbally it was delivered very in a simple manner, so that it reached out to all our participants. Thank you so much, sir. Thank you so much.
Thank you. I'm sorry for the inconvenience.
No problem at all, sir. No problem. This is all good. And I must also thank our director, senior scientific officer, and the coordinator of our climate change cell for guiding us in conducting this webinar. And finally, I must thank all the participants from diverse backgrounds, administrators, officials, academicians, students who have all participated in this webinar. And we also request that we'll be doing this series of webinars in future every month. So we request everyone to support us and join us and be enlightened on the topics of climate change and other relevant sectors. Thank you so much. Thank you, everyone.